We will be talking about the production of benzene through catalytic cracking. Cracking is a process that breaks large hydrocarbon chains into smaller ones. If we talk about catalytic cracking, the use of a catalyst is required while proceeding with low pressures and temperatures. Benzene is an aromatic that is used as a raw material to produce other industrial chemicals such as ethylbenzene, cumene, and cyclohexane. It is also used as a solvent in the pharmaceutical industry, and alongside with toluene and xylenes, it is used in multiple petrochemical processes as intermediate in the synthesis of aromatic derivatives. Benzene can be obtained by multiple processes. However, we chose to study how it can be obtained from toluene. The reaction, as we will see later on, takes place in a PBR because it requires a catalyst. As we have mentioned, ethylbenzene, cumene, and cyclohexane can be obtained from benzene. If these chemicals are industrially treated, plastics such as polyester, ABS, and nylon can be obtained.
It is important to know that you can obtain so many products from these three, recognizing the impact they have nowadays. For example, ethylbenzene is used primarily to make another chemical, styrene. Styrene is a chemical used to make latex, synthetic rubber, and polystyrene resins. These resins are used to make plastic packaging, disposable cups and containers, insulation, etc. On the other hand, cumene is used to manufacture other chemicals such as phenol, acetone, acetophenone, and methylstyrene. It is used as a thinner in paints, lacquers, and enamels. But the most important characteristic is that it is a component of high-octane motor fuels. We have already said that we can obtain ABS from cumene, but what is ABS used for? Well, ABS is also widely considered to be more durable, longer-lasting, and easy to recycle than PVC. Remembering, this material has a strong impact resistance and a strong heat resistance. But talking about nylon, nylon is a synthetic material widely used for textiles. It has a great strength, thickness, and elasticity. Nylon fabrics are water resistant, they dry quickly when laundered, and usually require little or no ironing. And if we ask us, what clothing is made from nylon? Clothing such as swimwear, activewear, lingerie, rainwear, and hosiery is made from nylon. Now you understand why it's so important the production of benzene?
The reaction studied is the disproportionation of toluene, which, as mentioned previously, it is a catalytic cracking. Nowadays, this type of reactions takes place in an FCC, that is, a fluid catalytic cracking. BASF's Valor is the most technological FCC so far, as it promises to maximize the process's profit and to increase the sustainability of the operation by having a higher catalyst effect. Nevertheless, for educational purposes, we will idealize the reaction in a PBR. A temperature of 490 centigrades and a pressure of 20 atmospheres are proposed in order to obtain a residence time between 1 and 400 seconds. It is known that both benzene and xylene are higher priced than toluene. In 2014, the selling price of benzene was 1.35 times higher than the selling price of toluene, at 24,000 Mexican pesos per ton. According to Mexico's Energy Department, in 2019, the demand of benzene grew 4.1%, representing 24.3 thousand of tons. It is also important to mention that our idealized PBR's volume is of 1,240 liters. We will see how this number was obtained later on. The disproportionation of toluene takes place at a temperature between 350 and 390 centigrades, and a pressure between 10 and 50 atmospheres. As we said previously, we chose 390 centigrades and 20 atmospheres to make the proper calculations. As the picture shows, toluene goes through catalytic cracking where both benzene and xylene are produced. Many catalysts can be used. Nevertheless, in modern cracking, zeolites are used as catalysts because these form chains with 5 to 10 carbon atoms, which are mainly used in the oil industry. For this specific reaction, we found out that the catalyst used is named ENCAT 100. Additionally, the zeolites produce branch alkanes and aromatic hydrocarbons, such as benzene. The zeolite is dispersed in a amorphous matrix, providing activity, stability, and selectivity, while the matrix supplies the physical properties that are desired.
For the reactor selection, our team chose a PVR because we need to remember that one of the most important advantages of using this type of reactor are high conversion per mass of catalyst and low operation costs. Meanwhile, our principal disadvantage within this type of reactor is the temperature control. Also, we decided to use this type of reactor because it is pretty much similar to an FCC. The problem we face with this process is that BASF Baylor has patented many of these catalytic processes, making hard to find information about these sophisticated types of reactor. Another important factor for the selection was the use of a catalyst, because we know that the proportionation of toluene requires the presence of catalyst, because in case of not using one, the time required would be infinite, causing a significant increase in the costs. And of course, we cannot forget that a PVR allows us to have an immediate regeneration. In order to achieve our main purpose, we chose a zeolite as an ideal catalyst. According to the literature, the use of zeolites as a catalyst causes the formation of carbon chains between 5 and 10 atoms of carbon. In addition, this type of catalyst produces branch alkanes and aromatic hydrocarbons such as our desired products, benzene. Another advantage of this type of catalyst is that the activation energy required to make the reaction to take place is lower. And obviously, as in many other catalytic reactions, we need to carry out with side reactions besides the main reaction. Many times, this side reaction can cause undesirable products. Along the course, we have been talking about the general mole balance of a reactor, and we know it is in minus out plus generation equals accumulation. And when we are talking about in and out, we are talking about the rate of flow that goes in and that goes out of the system. And when we are talking about generation, is the rate of generation of the product by chemical reaction within the system. And in accumulation, we talk about the rate of accumulation of the product within the systems. But that in this case, we're talking about a type of a continuous flow reactors. We can assume the accumulation is equal to 0. So that's why we cancel it from the equation. We know packed bed reactors are tubular reactors filled with catalyst particles, and we also know the principal function of a catalyst, that is to accelerate the reaction. So that's why we left the generation in terms of the weight of the catalyst.
Thanks to some more research, we found out that our values of pressure and temperature had to be different, so we changed them and we make the calculation for the volume of our reactor, taking in account the production of a day. With this, we could see that there are relations that two toluene will give us one of benzene, and from xylenes and aromatics. In the document that we investigate, we saw that this is one of the most used methods nowadays, and it gives really good results. We can also see that our concentrations are a little bigger than the ones we had before, so as the flow continue being 100 mole per hour. And with this, we could easily calculate the size of the volume, and it was the ideal. The obtained results now with these new values had really good sense with what we researched in the previous paper and the new one, where it says that it has to be really big amounts of temperature and pressure in order to have a really good relation and a really good reaction, because we are treating with naphthas, with oil, and these are heavy components. It is important to punctualize that we not only choose this because of the reaction, but because of the size of the reactor that is ideal for this type of procedure that we are studying.
One of the most important assumptions made in our process was the conversion, because our reactor is calculated with 90% of efficiency, and we know in the industry not all the processes can have a high conversion.